Silence. Okay, the movie is on. Shh. No, see, here we go. All right. I haven't done this in years. I think the last video I made was from 2013. No, that's actually a lie, but I think I made 3 last year. And I tried one this year. So here we go. Good old second hour. All right. Doing ellipses. Who has elliptical orbits, everybody? Earth. Who else? Planets. And then what did I just talk about? Haley's Comet. All right, from watching Cosmos episode 3, the new version. All right, so we had a little discussion about planetary motion, and now we're going to bore you. Okay, because here now we have. Okay, now look, I can't zoom out. Oh boy, this. Here we go. All right, see the circle? Okay, remember this circle equation? And I guess I can't really expand on this anymore. And who cares what's written up there? You read that later. That's not for your notes. I'll talk about all those things that are mathematically sound. Remember what I said about a circle? You can divide both sides by what? R squared. Okay, and then this is the standard form of a circle with a center h comma k instead of 0, 0. And all we did yesterday was 0, 0 ellipses. And we're able to hopefully graph those, through x-axis radius and y-axis radius analysis. All right, so far, how many minutes we in? Good. We don't have any technical issues. All right. Very excited. Okay, so now you might want to write these down again and reiterate the difference between a circle and an ellipse. And the difference is that the x-axis and y-axis radius or radii are different. Therefore, you get an oval. But now we're going to base it off of some h comma k, not 0, 0. And it's actually really basic grade school math to be able to do that. All right? And then guess what I'm going to do with all the rest of this stuff? I'm going to black it out. Don't even look. Oh, that's a little too much. Already a mistake. Okay, I'm going to black all this out because this is all tells you, I guess, that you have something to memorize. You have a chart to memorize, and you got to put all the letters with numbers and their formulas, and it's wrong. It's actually real basic and real easy stuff. One more question from yesterday, the most important question of all. Where do the foci belong? Where do they belong? Inside, but also along the, when you graph them, they belong along the major axis. Therefore, that will ensure the first thing that you said. They will be inside the ellipse. Just like I said, the sun is inside the Earth's orbit around the sun. And the sun is actually considered to be at one of the focal positions, or, being the focus of that. So I've heard. So again, just to reiterate, what's A? And don't overdo this, because we're going to do hyperbolas, and there's going to be A's and B's and hyperbolas that have a little different meanings. The most important thing to determine is who has the bigger radii, and therefore that's the biggest, or where the foci are. So all they're denoting is this first one. The bigger number is underneath the x squared. So therefore, it's a short, wide one. And then the foci are written, or graphed on the major axis. The second one just says the bigger number is underneath the y squared. Notice this. It's y minus k squared. The y value is always with, of the center is always with y. Sometimes people go in order, and we'll see that in an example that I have today. Be careful. And it's not that these are not going to be referenced. I know that was a double negative on purpose. This isn't English. Okay? But these letters and, H comma K plus or minus C just lead to confusion and make the robot student think they have to memorize a formula. And that's why I got them crossed off. So I will ask you, where do the foci belong? And all you have to do is do grade school math by counting to figure out where the foci land according to where the center is. Very simple. I hate the word vertices for an ellipse, just being giving my opinions as I always do in class, like how I tell you how I love Common Core every day. Vertices are the endpoints of the major axis. That was a lie. And then semi. What's semi mean? And we talked about these words yesterday. Have. It just lengths. This is such silly questions. All right. And then, it's the same old, same old. Same formula to find out what C is. That's where it comes from, and they derive that. We're just going to memorize. Okay? To find the foci, that's the C value, and to find that C value is from that relationship right there. Okay, and then certainly don't write this because this will be shorter set of notes today. I won't talk about planets anymore and all that other stuff. But all this denotes is, say we have a left-righter. And don't write this down. And certainly don't write all the letters. And you better not fall asleep. Were you here yesterday? Were you? Then get your head off that board and pay attention to this so you know how to do yesterday's stuff. You watched the video from 2013? Okay, I'm sorry then. That's good. Was I kinder in that video, or is it about the same? I was kinder. Well, that was pre-Common Core, Samulus. So there's a reason. Okay? All right. So this is what you do first. You find where the center is. Let's say it's right there. I'm pointing at this, so I guess I should. And then all you have to do is, okay, what's the x-axis radius? Whatever that is, you count that far left or right, my other left, and then left, and then graph those points. And then what's the y-axis radius? That's what I do to go up and down. And then that's all I need to draw the ellipse. And that's going to be grade school. I couldn't get Lexi to do that. She hasn't seen a coordinate plane, but Sammy Samulus could. She's seen a coordinate plane and could do that. And then you find through that Pythagorean theorem thing that they call it, but that c squared equals a squared minus b squared, and find the c value, and then you move c right and c left for an ellipse that is short and wide, and then graph that. So really there is no challenge today. Instead of being based off of 0, 0, you're based off of something other than 0, 0 for a center. It doesn't even say graph, but it's smart to graph the way I'm expressing this to you, so you don't have to look at that chart and try to formulaize this. You'll be destroyed in this chapter if you do that. What you need to do is get all of the things that I've told you. Even if it doesn't say graph, you want to sketch it so that you get all the things I'm trying to get you to understand put together. All right? So, for instance, you know what? If this was Common Core, you'd get in groups and then tell me what the center is. Or I could pick on someone individually. Remember that? That was fun. Day 1 of notes. All right? What is the center? Everyone should be able to answer that. Back in the 90s and early 2000s, when you were 3 years old or 2 years old, the students would say the answer all together. So 3, 2, 1, what's the center? Did you hear that? Wow. You guys are on the internet. You're famous. You're right. So here's why you would graph this. Okay, I'm not good at trying to, picture this in my mind. So I'm just going to sketch it on a piece of paper. Left 2, 1, 2, 3, 4, 5, up 5. There's where my center is. Every single thing is based off of this now. For instance, what is the x-axis radius? Don't answer. Answer in, what is the x-axis radius in 3, 2, 1, go! 3. Did you hear him? All right, say it louder, everyone, so that we can, really pretend we like each other. No, I'm just kidding. That's a bad joke. I love you guys. I really do. If that makes you uncomfortable, that's too bad. All right, and then what's the y-axis radius? Yeah, you're right. I screwed up. My best buddy in class reminded me that All right, so what does that mean? I go 3 from the center. What? 3 what? 3, 2, 1. Left and right, Mr. Samulus. 1, 2, 3. So I could actually graph this without finding any information. Oh, no. I didn't give a good coordinate plane. Okay, and I go 7. 7 up. Oh, I'm thirsty. 1, 2, 3, 4, 5, 6, 7. I'm going to try to guess that one. And 7 down. 1, 2, 3, 4, 6, 7. Hopefully I counted right. Okay, then I can actually graph this. Didn't say graph, Mr. Samulus. I think it's a good idea. Because where do the foci belong? They belong up, 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 and down. So I'm not really doing a good job on All right, so letting you answer that. Now we know a squared is 49, b squared is 9. This a is the bigger number, so a squared is 49. It's not a big deal. You should never get a negative number. Subtracting those the wrong way. And then what we need for this is probably a decimal. Can someone help me out? I'll pause this as it takes 7 minutes for someone to actually get their calculator out and help a guy. It only took 10 seconds. 6.3. So what I want to do is go, okay, but I'll show you how we can write the foci. I just do want to graph them though. So 6, holy smoke, 6.3 is like really close to those endpoints. So I do like doing that. Remember I said the farther out the foci are, the more elliptical it would be. And that's pretty elliptical. That's pretty ovular, if you want to call it that. But now here's how we can write the foci. And this is actually how I prefer you write them. And I'll do it the first time for you. Okay, go back to the square root of 40, which actually is, what is that, a number? Isn't that 4? I was never good at math. 4 times 10. What's the square root of 4? 2 root 10. And then this is how I'd like you to write this. Now remember, you moved from negative 2 comma 5 up 2 root 10 and down 2 root 10. So the foci are negative 2 comma 5 plus or minus 2 root 10. Up 2 root 10 and down 2 root 10. And that's how I expect you to write that. I mean, you could say negative 2 comma 11.3. I'll allow that. You get it? 6.3 plus 5. And then negative 2 comma, oh, here we go again. Negative 1.3, right? Okay, you could do that too. That's fine. Or you could leave it in an exact form and do that. But if I do ask it for an exact form, that's how you got to write it. Exact form means leaving radicals as they are, not evaluating them. Okay, here are the questions. What's the length of the major axis? 14. What's the semi-major axis? 7. What is the length of the minor axis? 6. What is the semi-minor axis? 3. These are all the silly questions that they ask you. And then what are the vertices? I am going to write that down so that you get this word down that I really do not like for ellipses, because I really feel like there's two sets of vertices. There's the minor axis vertices and the major, but for some reason they like the major axis vertices. So they're major axis, so they call them vertices. Okay, so one of them is negative 2 comma. Now never do a plus minus thing when you have a number. So I don't have a square root for this. I went 7 down, so that's negative 2 comma negative 2. And then I went 7 up, which is negative 2 comma 12. So that's these. These are considered the vertices. I don't know why these aren't. Somebody made a decision about that. So we're just going to stick with what the book says. Just being honest. Okay. That's enough time. In 3 seconds after I ask the question, yell it out loud so everyone can hear. What is the center? 3, 2, 1, go. There was 2 different answers. I got half of you. You just went right in order. What's the actual answer? Is it 1, negative 2, or is it negative 2, 1? It's negative 2, 1. You probably didn't get to hear that in the video, but definitely heard a couple, if not more, say 1, negative 2. You can't be a robot and just go in order, left to right. Negative 2 is with the x, and 1 is with the y, so it's negative 2 comma 1. All right, so you start with that. Negative 2, 1. Just stay green. And then the x-axis radius, not even going to bother you, is 5. Y-axis radius is 4. So this is almost circular. 1, 2, 3, 4, 5. There's a vertice. 1, 2, 3, 4, 5 vertice. Let's just do this fast. 3, 4. 1, 2, 3, 4. All right, and then you could draw the ellipse without finding all the other stuff, but we'll find it anyway. And then we know it's 25 minus 16. Is that nice? Isn't that nice? Which is plus or minus 3. Now, Vertices. Okay, again, 3 comma 1. It's only the endpoints of the major axis. And then 1, 2, 3, 4, 5, 6, 7. Negative 7, comma 1. This is what I mean about Sammy Samuels being able to find the vertices after telling her. That's what the vertices are. The endpoints of the longer part of the oval. Okay, Dad. And then she can count and find them. Yes, 12-year-old. Okay, fumble, by the way. And I do not allow this. You cannot say the vertices. By the way, where do I have to go for the vertices? Left, right, or up, down? Where do I have to go? Do I go left, right to graph them or up, down? Oh, no. Which way does the major axis go, everybody? Left, right. So which way did the foci go? Left, right. Okay, did I make a mistake? Hold on. Someone's raising their hand. That makes me nervous. Hacker, I did that on purpose. Were you paying attention, YouTube? No, you weren't. You let me do something wrong there. Okay, so I go up 5, right? Yeah. So we'll put that in red. 1, 2, 3, 4, 5. Oh, so I yelled at you 1, 2, 3, 4, 5 for doing the center wrong, and then lo and behold, I do the radii wrong. The y-axis radius is 5. 1, 2, 3, 4. That's stunning. YouTube. I'll have to delete this video. I can't be shown to be making a mistake. All right, anyway. And then, which way do the foci go now? That's why you didn't answer. Which way do they go? Up and down. And how far do they go up and down? 1, 2, 3. And then 1, 2, 3. Is that right? 1, 2, 3. 1, 2, 3. Okay, there we go. Just got a little nervous there. Another mistake. But not. Okay, I will not allow you to do this. 3 is a number that is already, it's a number, it's not a square root. So I will not allow you to be lazy and say the foci are -2 plus or minus 3, comma 1. The only reason that's allowed with a radical is that's the exact form. Okay, you actually will calculate those, if you want to call it calculate, and say one of them's at -5, comma 1, and the other one is at 1. Did I do that right? I feel like I'm screwing up. -2 minus 3 is negative. Oh my gosh, I did it again. This is a disaster. I go up, so it's -2, comma 1 plus or minus 3. Oh my gosh, not enough coffee this morning. So it's -2, 4, and -2, -2. And the other reason I feel silly about it, they're right here. I could have just found those coordinates. But what I was trying to tell you is this will not be allowed. That's laziness. You can calculate 1 plus 3. In the previous one, if I made you put this in exact form, then you have to leave the radical intact. So the only way you can write it is in plus minus form. That make sense? Okay, sorry for my mistakes. Oh, lack of perfection. All right. Where am I at? Okay, probably could have kept that offline. All right, go ahead and have a chance to write this down. So all this other stuff is work, though, that I have set up. So the question's like there. This is just what you should do as a student in order to figure it out. And even the book says so. So take a minute to take a look at that. I still have the wrong vertices. Because remember, I made that mistake. And I didn't change those that was written here. The vertices are actually here. Holy cow. I'm going to leave it. I am human, although I wish I was an alien. Where did that just... Do you see that? Now here comes the computer. Here it comes. Here it comes. Where the heck are we? Whoa, whoa, whoa. What? Oh, I just went to a different page. That's that stupid touch screen. All right. You have to do 1, 2, 3, 4, 5, 6. Thanks, ma'am. And then -2, comma. Chock full of errors. See, I told you. I was a little nervous going back to the video, making all these mistakes. Okay, all right, now we'll pause. I thought you said it's true. We were talking about Braveheart, which is very important in math. All right. So, you're like in the dark, just reaching for answers. If you don't I can't even think of a reference. You're an old man looking for soup in a deli. You're going, where's the soup? And you're not even asking for help when you don't actually graph this question. You don't graph it. So the book even says so. I couldn't even, I could maybe, but it'd be so intensely hard. And I'm going to be so mad at you, and I'm going to grade your quiz accordingly. If you have a question like this and you don't have a picture lined up. Okay, and even the book says that you do this. Okay, so I read it. Standard form of the equation of ellipse. That means I have to do this. That means I have to fill this in. And I don't know yet, but I do. I picked out that it's a squared's underneath the x squared from the very beginning. But that's fine. It'd be one or the other. So I have to fill in these missing parts. I lost my k. Whose major axis has endpoints. -2, -1, and 8, -1. You're a silly, silly, silly fool if you don't graph those 2 points, and hence that's why I know the bigger number is underneath the x squared, because it says the major axis endpoints. Instead of saying that, it could have said what instead? The vertices. That word I don't like, that, they're being cryptic. They're trying to add vocab to you, I feel like. They're trying to be little tricksters. Okay? And whose minor axis length is 8. Okay. Well, the first thing is, how did they find this? Where does this belong compared to the vertices? It belongs right in the middle. And I could have Sammy Samuelus, the 12-year-old, find that. Hey, Sammy, just by counting, find the middle of those 2 points. Okay, Dad. 4, 5, 6, 7, 8, 9, 10. Okay, so I should only go 5 this way or 5 that way. So therefore, the center, just by counting and grade school coordinate planeage, if I can make up another word, 3, -1. Now look what you found. You have 4 things to fill in, and you just filled in 2 of them. You filled in the center, so I have -3. I don't know why that disappeared. And then -1 is minus a -1 is +1. So you have, a lot of your points. I probably won't make that the most. The most points is getting, the bottoms. All right. And then, hey, what's this? How far is that? I already said the number. 5. And then how far is this? We didn't say that number. 4. So what belongs underneath x squared? What belongs underneath x squared? 5 squared, which is 25. And what belongs underneath y squared? 4 squared. It's over. Good night, Irene. Uh-oh. Oh, what? It doesn't say you didn't find a foci. I think I did that for giggles. Huh? Yeah, it just says write the equation. And then here's another one. Oh, no. So it's the same thing. Find the equation from the given information. I'll let you write that down for a second. Then we got to complete this. Okay, so just write that I give you the foci and the major axis length, which is fine. Okay, so that's what you got to do. You got to fill in the missing parts, and we'll fill them in as we do our math. 2, -7. 1, 2, 3, 4, 5, 6, 7. Probably could have done this offline. Well, let's watch that video when the guy just says numbers. 2, 1, 2, 3, 4, 5. And actually, just to remind myself, I like making foci X's so I don't forget what I actually wrote there. So that can happen. All right, already made a couple mistakes. Hey, so where does the center belong even compared to the foci? Right in the middle. Here we go, Sammy Samuelus. Okay, Dad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. Boom. Shaka. Alaka. Center. 2, -1. That means I have this part. 2 + 1. Right? So simple. Then the major axis length is 16. So that means I move what from here to here? Well, actually, no. This is all 16 from here to here, the major axis length. So how far do I move from the center up, and how far do I move down? 8. 1, 2, 3, 4, 5, 6, 7, 8. Who do we appreciate? All right? And then, so therefore, I don't need to graph this. All I need to know is, oh, and where does that go under? Does that go under x squared or y squared? I have these, so this stays. Where does that go? Underneath x squared or y squared? Y squared. And what goes underneath there? Is it 16 squared? Is it 8 squared? Is it 8? Is it 16? Which one is it? It's 8 squared. Actually, I don't want to write that there. I want to write this here where I put the parts that I need, and then I continue and put the final answer there, right? Now, how do I find this value? Well, what's this move from here to here? How far is that? I don't have the time. It's simple counting. It was 6. What does 6 represent in this little equation right here? Not A, not B. C. It's the foci. So 6 squared equals, and then what does 8 squared or 8 represent? A or B? Not B. It's A because it's the major axis. It is the larger of the two. Okay? So it's the larger move. It's the major axis. It is the A value. So that is one thing you need to know about ellipses. The major axis is the longer axis, so therefore A is the larger number. Okay, so you got to put the parts in the right spot before you can continue. And yes, you will get, oh, there's where the center was. I knew I had some blanks over there. 36 minus 64. This is 64, and I'm going to subtract it. Sure, you're going to get a negative here. And I can't even think. Oh, let's do this online. 64, 54, 34, 24. Is that right? Let me do it over. 54, 44, 34. I went a little too fast there. And then minus another 4. Is that 30? Can someone just take 36 no, is it 28? But it's negative. But what's a negative b squared equals a negative 28? Positive. And then what do? Do I put the square root of 28 or 28 underneath here? Oh, it's b squared that goes underneath there, not b. All right? I hope I did that correct. Now we'll do it. I'm only going to have time for one complete the square. Sorry, second hour. Too much Braveheart, Planet Talk. Some technical difficulties. That was my fault, though, because I haven't videoed in so long. He's putting his books away. It's the most important lesson. So at the 26-minute point, you should probably start this video. Mm-hmm. Hey, how do I know this is an ellipse? You don't know that yet. Look at the two numbers in front of the y and x squared. They are, well, no, but look at them. They are different. So when I divide by a number, they're going to cancel and have different radii values underneath. And that's what you got to understand. So now you really have to pay attention and remember how we completed the square with a parabola. But the first thing you need to do is, okay, fine, I have a little panic, but I remember doing this with circles. I at least got the x's together. I at least grouped the y's together. I did not put a blank for a reason, though. And I'll tell you what that is in a moment. And I at least remember that any non-x or y, I added it or subtracted it to get it on the other side. So we at least remember that. Completing the square with a circle. But now we got a problem. You cannot complete the square on x squared and the x there, nor with the y squared when there's a number in front. So now what we're going to have to do is what we had to do with parabolas. What did we do with that 9? Let me give you a hint. After I grouped these two together, what did I do with the 9? You took it out. Only the 9, not the x. You're not getting your greatest common factor. You just need to have this to be 1x squared, and then we'll put a blank. And those that were able to complete the square with our parabola section, you're going to be fine. Okay, what does 18x become, or negative 18x become? 2x, and then we put our blank. Whatever you do to one side, and this is what makes me mad. When things get more complicated, you actually lose your basic skills. I'm adding something to the left side, so I got to add it to the right side. And this is the number one error that people do. They don't do the basics. Okay, and then what do I got to do with the 4? Take it out. So make it a plus, and then pull out that 4. Okay, I gave myself ample space. I shouldn't have to ask you, what does 8y become? Whoa. It's the stupid touchscreen aspect of this computer. And then I got to add a blank here. And now my question is, what are the blanks? When I say complete the square, you say take half the middle term, and then what? Square it. And what goes in this blank? But then those that remember what happened with parabolas, or actually what happened with the left side, I actually added what? Not 1, but 9. You added 9 times 1. That is not calculus. Okay? You actually added 9 to the left side if you distribute that 9. So I have to add 9 to the right to counter the balance. And then, of course, what's this blank become? 1. But then what's this blank? Okay, then completing this square is not a big deal. That's why we don't have, I'm just spending a lot of time to explain it. This becomes 9, x minus 1. I'm sick of teaching factoring. At this point, if you don't know how to factor, I don't think it's ever going to happen. Just being honest. Whoa, that's just so rude. We have factored since August. And we have factored every single day almost. That's not true. But I would say out of 5 days in a week, we probably factor on average 3 out of the 5. I think that's pretty close. All right. And then I'm going to divide both sides by 36. And then 9 over 36 is 1 over 4. 4 over 36 is conveniently 1 over 9. That equals 1. And now what I forgot to talk about, okay, fine, the vertex is 1 comma negative 1. I don't have time for the foci. Well, actually, I do have to find the foci to find eccentricity. So 9 minus 4 is 5. C squared equals C equals root 5. 9 minus 4, I just did that real quick. Here's what eccentricity is. And I'm going to go back up to here and remember talking about things being close to circular and things being close to elliptical. We can actually analyze it numerically. Okay, if eccentricity, which is just this expression, C divided by A, if C divided by A is closer to 1, then you have a more elliptical. The foci are really spread out far apart, and you get a real ovular situation. When the foci are really close to the center and not very far, like my first drawing from last year, then it is close to circular. All eccentricity is, for this one, the square root of 5 over the square root of 9, which is 3. And then you could calculate that number on your calculator and analyze from that.